Hi there, pre-calcers. Just wanted to run through a quick intro to Chapter 12. This is meant for you to be watching after completing the initial reflection on radian units. So hopefully you've already done that. If not, go ahead and pause the video, go back and do the reflection first. Then you can watch the lesson here. So I want you to have thought through and work through that first. So from 12.1, the topic here is dealing with radians, arcs, and sectors. Really, the arcs and sectors stuff is pretty straightforward and simple. The radians, I think, is really the tricky part to this whole unit. And radian as a unit, I think, is kind of one of the more confusing units that's out there. And so I want to really hash this out about what a radian is and really start to develop a real intuitive understanding about what these units are. I don't expect this to all happen here this week. We just want to be working on this and building this so that we have a good intuitive sense for what a radian is. And the reason why is radians in advanced mathematics, radians are the units that are most commonly used. So we want to be comfortable with those. Most people, I think, are already fairly comfortable with the idea of a degree. We have an idea that 360 degrees is in a full circle. 1 degree then would be 1/360th of a full circle, and we kind of understand that. We kind of have an intuition about those angles. If I tell you a 45-degree angle, you can kind of picture in your head what a 45-degree angle looks like pretty easily. But if I tell you, oh, the angle pi over 4, well, that's an angle in radians. It's probably not as intuitive, even those happen to be the same angle as 45 degrees, probably don't have that same intuition with regards to those. So we want to be building that. And to start off by understanding what radians are, kind of that just as a similarity to what we did with degrees here. 1 degree is 1/360th of a full circle because a full circle is 360. Well, a full circle, you can think about that as the circumference of the circle is 2 pi times the radius. So we just assign the circumference of the circle. If we have that's 2 pi, then that would be the angle in radians that we would be using. 2 pi would be equivalent to 360 degrees, that full circle angle. So then 1 radian would just be 1 over that of a full circle. So 1 radian is 1/2 pi of a full circle, and 2 pi is a little over 6 1/4. So a radian is a little less than 1/6 of the angle of a full circle. So why do we care about this? Why do we care? Kind of at a basic level, uh, circles are all about pi. So it's much more convenient when we're dealing with circles to have a unit for angles that's relative to the thing that we use to define the circle, or that circles are really defined from. So one intuitive way, or kind of the best way entry point to understanding this idea is we're relating the angle measure here to the radius of the circle to the arc length. All of these things now are going to be connected. So if I, for example, have an angle of 1 radian, at again 1/2 pi of a circle, that is going to be an angle here. It's about 1/6 of the 360, right? So it's going to be kind of in the neighborhood of 60 degrees. You can work out what it is exactly. But if that angle is exactly 1 radian, then the radius here and here, of course, are going to be the same. But the arc length, this arc that's subtending that angle, is also going to be equal to whatever the radius of the circle is. So essentially, what this angle is saying is that if I have 1 radian, that means the arc length here is equal to the radius. If I increase that and say, well, theta now is 2 radians, then in that case, the arc here is going to be 2 radii. So an angle of 2 radians means the arc length is 2 radii. Simple as that. So if we extend all the way around 360 degrees, that's 2 pi of a circle. That's saying that the circumference is 2 pi radii. And that's should sound familiar because we know all about the circumference of a circle is 2 pi times the radius. So that's kind of where this all comes from. And we can simplify this by using the arc length formula. Any arc length we can find using this formula right here. The arc length is equal simply to the r times